A mirage is a fascinating optical illusion that often captivates observers, especially in hot, arid environments like deserts. This phenomenon occurs when layers of air at different temperatures interact with light, creating the appearance of distant water or other objects that are not actually present. Understanding the science behind mirages sheds light on the complex interplay between temperature, light, and human perception. Mirages are the result of the refraction, or bending, of light rays as they pass through layers of air at varying temperatures. On a hot day, the ground absorbs heat and warms the air directly above it. As a result, the temperature gradient creates layers of air with different densities. When light travels from cooler air to warmer air, it bends away from the denser medium. This bending causes the light rays to curve and create the illusion of an object, such as water, where none exists. This effect is most commonly observed in deserts, where the contrast between the hot sand and cooler air above creates the ideal conditions for mirages. Types of mirages. Inferior mirage. This is the most common type of mirage and is typically seen on hot, sunny days. An inferior mirage appears as a pool of water on the ground, which is actually a reflection of the sky. This occurs because the light rays bending through the hot air near the ground create the illusion of water. Superior mirage. Less common but more spectacular. A superior mirage occurs when a layer of cold air lies above a layer of warmer air. This condition can cause distant objects, such as ships or icebergs, to appear elevated above the horizon. Superior mirages are often seen in polar regions where temperature gradients are more pronounced. Fata Morgana. This complex type of mirage is a more distorted and layered version of the superior mirage. It can create multiple images of an object stacked on top of each other, making distant objects appear as though they are floating in the sky. Fata Morgana mirages are often seen over large bodies of water. Historical and cultural impact. Mirages have fascinated people for centuries and have played a role in various myths and legends. In ancient times, travelers in deserts often mistook mirages for actual oases, leading to confusion and sometimes perilous situations. The term mirage itself is derived from the French word mirer, meaning to look at. In literature and art, mirages have been used symbolically to represent illusions, unattainable goals, or deceptive appearances. The ethereal nature of mirages often evokes a sense of mystery and wonder. Scientific significance. Studying mirages helps scientists understand the behavior of light and the atmospheric conditions that affect its propagation. Research into optical illusions like mirages has applications in meteorology, navigation, and even space exploration. By learning more about how light interacts with different media, scientists can improve technology related to imaging and visual perception. Conclusion. The mirage phenomenon is a remarkable example of nature's ability to trick the human eye. Through the interplay of temperature, light, and atmospheric conditions, mirages create illusions that captivate and mystify. Whether viewed as a shimmering pool of water on a desert road or as floating images on the horizon, mirages remain one of nature's most intriguing optical illusions.